So r of t is going to be our position vector. So if you have like r of t equals, say, x of t I hat plus y of t j hat. So that's going to be our position. I know in Calc 1 they call it s. Here we call it r. So this is the position vector. So position vector. Position. I don't know what's fun to say that. When you take the derivative of position, do you all know what you get? Velocity. Yeah, very good. So v, you'll call it v. So v of t is equal to r prime of t. And you would just take the derivative of each, right? So you would get x prime of t I hat plus y prime of t j hat. And this is the velocity function. Velocity, yeah. It's a velocity vector. It's the tangent vector. It's going to be tangent to your graph, by the way. Yeah. And then, what's the derivative of velocity? Acceleration. So this is r double prime, r prime prime of t. This is the acceleration vector. Right, they're vectors. And speed is the magnitude of velocity. So the speed is going to be the magnitudes. This is the square root of the component squared. So that's the speed. So speed. It's speed. Okay, that's not a vector, right? That's a scalar. That is
the v supposed to be prime?
Oh, that's not supposed to be prime. Thanks. Yeah, thanks. That's points.
Okay.
Well, the camera's looking at me. It's really weird. Okay, so v. It's like an I. Yeah, thank you. What is it? David. I should write it down. David. Thank you, David. Thank you. I appreciate it. It's good. All right. So I have a couple examples in my notes. That one's really cool, but let's do one. Let's do a problem. So you see how to sketch.
Are they long problems?
Well, I'm skipping one of the long ones. So I'm going to do like one that's relevant for the whole. I have a really interesting one that's very long. So I'm just going to skip it and do one that will help you through the homework. And then we'll do like a test level one. So that'll be a good way to do it. So this next one is a decent problem. It's going to require some sketching. So on the test, you do not have to sketch anything. Okay, so I want to emphasize that. So don't worry about graphing on the test. It's really tricky. So I'm going to show you how to do it. So sketch and find is actually pretty hard. Like if you don't know how to do it, it's like, what? It's a little bit weird. So sketch and find the velocity and acceleration vectors Okay, sketch and find the velocity and acceleration vectors at t equals 0 and t equals 2. So we're going to sketch and find both. And they give us the position function, which is r of t equals t squared minus 4 I hat and plus tj hat. So plus tj hat. Again, I'm not going to ask you to do this on a test, but there's a bunch of them in the homework. So we'll do this one, then we'll do like some test level questions. On the test, you'll actually have a differential equation. Sounds fancy. You'll be given the position function, and you'll have to retrieve. Or you'll be given the acceleration function. You'll have to retrieve the position function. You'll just integrate a couple times and stuff. All right. So maybe before we do anything, we should graph this function, right? We should see what this even looks like. So solution. So in the homework, all the graphs are multiple choice, which is really nice. So this is your x, and this is your y. So x here is t squared minus 4, and y is equal to t. Okay, and y is equal to t. So I guess now what we can do is replace t with y over here. So it'll be x equals y squared minus 4. Okay, y squared minus 4. Just plugging the y in there for the t. Okay, so this is a parabola that opens sideways. It's a sideways parabola. It's a sideways parabola. Let me graph it over here. So like if y is 0, x is -4, so it's like this. And it's just gonna, and then when y is 2, x is 0. So it looks like this, and it just does something like that. That's the parabola. Okay. So if you plug in 0 for y, x is -4. If you plug in 2 and -2 for y, at -2 you get 0, x is 0. At 2, x is 0. So, and again, it's multiple choice in the homework. You could find the orientation. The orientation is like this. I'll leave that to you. So the orientation will look something like that. You know, plugging in numbers, like plug in t equals 0, plug in t equals 1, like before. Like you would just, I mean, we could do it, I guess. Watch. Why not? It's college. T, x, y. So 0, 1. Let's see what happens. So when t is 0, x is -4, right? X is -4. And then y is 0, right? Y is 0. And when t, so we're here. And then when t is 1, x is -3, and y is 1. So we're here. So we're up here. So it looks like it's going that way. It's a -3, 1. That would be the next point. All right. Hard part's coming up is the sketching. Okay. Before we do that, though, we have to find the velocity and the acceleration. So how do you find the velocity? What do you do?
The derivative.
Yeah, the derivative. So I'll write it as v. Okay. So I'm going to write v of t. So the velocity here will be 2t I hat plus j hat, right? Because the derivative of t is 1. So 2t I hat plus j hat. If you like, you can write it as 2t1. If you want, you can write it like that, right? 2t1. And then the acceleration would just be the derivative of v. So that would be 2, 0, right? 2, 0. So like that. Acceleration is constant. It's the same. Same vector. That's the acceleration. All right. So it's a constant acceleration. So it's kind of like as it's going this way, it's slowing down because the acceleration is going this way, right? So as the particle is going this way, the acceleration is going that way. So it's slowing down, and then when it's going this way, what's it doing? It's speeding up. Yeah, it's accelerating, speeding up. So it's slowing down, then it's speeding up. Kind of interesting, right? So it does tell you something about the physicalness of it all. So we have to plot the vectors. That's what it's all about. So let's focus on t equals 0. So at t equals 0. So we need to know where we are at t equals 0. So where even are we? So we have to first plug it into r. That's the tricky part, I think. So r of 0. I think I already did it, but let's do it again. It's -4, 0, so it would be -4 I hat plus 0 j hat. So it would be -4 I hat plus 0 j hat. So that's going to be here, -4, 0. So there's a vector, and the terminal point of that vector is there, right? Because it's a vector valued function. So there's like a vector coming from here and ending here, right? This is a graph of endpoints, right? If you think about it, right? Because you plug in a t and it gives you a vector. You say, where's the vector? This is the collection of endpoints of all the vectors. It's kind of weird, right? So that vector ends there. That vector ends there. So we're here. All right, so now we're going to graph the velocity vector. So v of 0. So v of 0 would just be this. So you plug in 0, so you get 0, 1. So you get 0, 1. So that would be the velocity vector. So when you draw your velocity vector, you have to draw it starting here. Okay? That's the important part, because that's where you are at t equals 0. It's up, hey! So we're here. So this is v of 0. Right? Because that's where you started. That's where you started. Everyone see why it's there? You see it? Everyone see why we draw it there? Because that's where we are. That's the tricky part. Like, it's like if you didn't know that, where would you draw it? And now we have to do the acceleration. So the acceleration vector is just the same. So 2, 0. So the acceleration vector is here. That's your acceleration vector, a of 0. And again, you draw it from there because that's where you are, right? You're at negative 4, 0. Do you all do this in physics or no?
Yeah.
You do? You have to graph the vectors like this? Oh, it's way more complicated? What? Oh, yeah. From here, you plug in t equals 0. No, good, ask. It's important. Good, Urash. Yeah, Dane.
Oh, it's for t is on the x-axis, right?
T is not.
T is not?
No, t is just 0.
Okay.
Why? What's up?
I'm confused as to why it's
Why it's here?
Yeah.
Ah, it's the hard part, Dane. Good. It's because, Dane, when t is 0, you have to find out where you are. So you plug 0 in here.
Okay.
And it gives you this.
Oh, negative 4.
Yeah, that's how you know to draw it there. That's the hardest part, what Dane asked, right? So you draw everything from here.
Okay, that makes sense.
Yeah, it's tricky. It's really, really tricky, I think. If you don't know how to do it, it's like, oh my God. All right, let's do the next one. So at t equals 2. So before we do anything, where do we have to plug the t into? Into which one? Into R to find out where to draw the vectors. Good! So R of 2, plugging it in. I've lost so many points tonight. 4 minus 4 is 0, so we get 0 I hat plus 2 j hat. So just 0, 2, right? 0, 2. Yes, Dean?
One more question. Your velocity only goes up one space.
Yeah, that's a bad picture.
It equals y. Your y is 1.
Yes, because the y is 1.
And then the acceleration
Goes over 2.
Okay.
Yeah, everyone see what he said? It's really important. It only goes up 1 and it goes right 2. Yeah, it's important. I mean, yeah. So you do this in physics, though. It's kind of cool. You know, maybe. I don't know. Maybe you don't. I don't know. Maybe not like this. All right. So v of 2. So we're plugging it in here. So it'll be 4, 1. Right? 4, 1, 4, 1. So from 0, 2, from here, we go up 4 and right 1. 1, 2, 3, 4, right 1. Boom, there it is. That would be the velocity at 2. Right, from that point. Right, from 0, 2. So from 0, 2, we go up 4 and right 1. And then the last one to do is a of 2. So a of 2 would be just 2, 0. And then so it's the same as before. From here, we just do 1, 2. So there we are. This is a of 2. So that's it. It's a terrible picture, but it's better than nothing. So, everyone understand why we're drawing them where they're supposed to be drawn?
4 over and up 1.
Did I graphed it wrong? Oh my God. Oh, that's so bad. That's so bad. Oh, that is so bad. Yeah, that is so bad. Oh, wow. Oh my God. I think the whole class should get for that.
Yeah.
Totally.
Oh!
This is how many points you getting?
What, Michael? No, I'm kidding. It's all right. I did it on purpose. No, I never mess up on purpose. I'm not one of those people. No. I don't believe in that. Everyone okay with that, though? Any questions on? Everyone see why we had the draw starting here? I think that's the trickiest part. So you have to first plug in. Thank you, Tori. You first have to plug in the numbers into R to find out where you start. Okay, that's the hardest part. This will not be on your test. Don't worry. Okay.
That's kind of easy though.
Huh? I think it's hard. I think people would mess up on this. I mean, I did. Huh?
Yeah.
You see it? I think this is really hard. I think you know what happens, Dane? People forget where to start the graph. Yeah. Huh? No, I'm not going to. See, I'm not going to start. I'm not going to.
Graphing for extra credit.
Yeah. No. You don't need extra credit.
More actually? Aren't we at like 6 points?
We got nothing.
Yeah, the whole class like.
Somebody's at 8 or 10.
Out of 4 minutes.
Oh, yeah.
Was everyone looking at me? All right, wrong section. Okay, I gotta get focus. We're doing 12-3. All right. All right, let's do a problem.
So is that it for this problem?
That's it. That's it. Now we're gonna do a test level question. Nah. So there's some easy ones on the. There's some in the homework where you just have to like do this. That's really easy though. I think you can do stuff like this. Let's do one like where you have to like work backwards. So like let's do a hard one. What's terrible? Maybe not terrible. Ooh. Let's do number 6. Let's do number 6. Maybe that's not so bad. Number 6. So number 6. So number 6, they give us some stuff. They give us A of t is 3 I hat plus 3 k hat. They give us this. And they give us some conditions. It's a differential equation. They give us v of 0 is, I already forgot. Uh-huh.
And then R0 equals 0. I guess it's 0 vector.
Yeah. It looks like that?
It's just bold.
Okay. Thank you. Thank you. So this is a differential equation. This is the second derivative. This is r double prime, right? So you have an unknown function, r, involving its derivative, or more. So this is really r double prime. So it's actually a dE with vector valued functions. The question is to find v of t, r of t, and r of 9. So it wants a bunch of stuff. So it wants v of t. So part A. So find v of t. That's part A. So I have to find this. Find this. So to find v of t, you got this. Yeah, you just integrate this one time, right? Yeah, absolutely. So v of t, this is what you'll have on your test, right? So v of t, so you integrate this, it'll be 3t I hat, right? 3t. Oh, I like this. 3t I hat plus 3t k hat.
You forgot the T.
I'm not done. Still not done. Yeah, 3t k hat. What's that?
You forgot the J.
What J? This is not there. It's not in the problem, is it?
Exactly.
No.
Yeah, the velocity has a J.
Yeah, but there's no J here, right? So there's really a 0 J here, right? OJ.
An integral, then it's
If you integrate 0, what do you get?
A constant.
A constant.
Reabsorb the every constant.
That's a point. I'm kidding. No, thank you. So plus, it'll get, so yeah, when you integrate this, hardcore, Anna. So this gives you a CJ. CJ is TJ's brother. No, I'm kidding. But it gives you a CJ. But the CJ is a constant. It gets absorbed into our vector. So you don't have to worry about it.
I'm going to mess that up.
You won't mess it up. I believe in you, Rafael. Yes.
So even with that 0j component, we have a full C vector?
Yeah. Yeah. Mm-hmm. Yeah, because that'll have a that will have a C component from the J.
Okay.
Yeah, a J component from that. Yeah, that. How do we find the C? What do we do now? What do we do? Yeah, plug in this. Yeah, very good, Tori. Very good. So V, I'm not going to mess up anymore. V of 0, it's just late. This is, all the T's become zeros, right?
Really late.
It is late, right? It's good. It's like 8:30. So this is going to be 0 I hat plus 0 k hat, okay, plus C, and that's equal to, what should that be equal to? 8 j hat. All right, 8 j hat. 8 j hat. So C is just that you don't even need to write the zeros, okay? You can just put C equals 8 j hat. Okay? Because the zeros are there, they're implicit, they're implied. Fun word, implicit. Means to take a differentiation. What do we do next to find V? What's the last step? Take the C in, plug it back in. Very good. I'm going to come to this board here because I'm running out of room. So then finally V of t is going to be, well, not finally, we're almost there, plus 3tk hat plus, and what was the C? 8. Oh, look! That was nice, because now we have the j hat. Now it magically appeared. A long lost friend is returned. That was fun to say. So now we have to find, part B. So they give you the steps on these, so I suppose I'll give you the steps on the test. Part B is to find R of t. Usually you just have to do part A and B on the test. You don't have to do part C because it's boring. Part C is to find like R of 9, like plug in 9. Like, it seems like bonus points if you did it right, or like extra loss if you did it wrong. So I'll probably just ask you A and B. I will not ask you to plug in numbers, because then if you mess this up, it's like double pain. How do you find R? What do you do with this? Integral, yes. Awesome question. So R of t, this will be 3t squared over 2 I hat plus 3t squared over k 2 over 2 k hat. Whoa. What happens when you integrate 8? What do you get? 8t j hat. What's missing? The plus. The c, the vector, the giant c vector. That's not giant, but I just put a big c. Good. It's not so bad. I like this better than the graphing, don't you? Yeah, right? Yeah, I wouldn't want to have to graph on the test. So I generally don't like putting stuff on the exam that I wouldn't want to do, because why would I do that? That's just, I mean, if I wouldn't want to do it, why would? Now you just plug in 0 and set the whole thing equal to 0. Right, so, because that's we're using our other initial condition. Ooh. So that's what they're called, by the way, initial conditions. Yeah. Oh, look, they're all going to be 0, right? So good. So I'll write OI plus.
You already know it's 0.
Oh, okay, all right. So, but I'll write it anyways. OI plus OK plus OJ. All famous people except OI and OK. Plus C equals what? Oh, it equals 0. Yeah. Oh, it equals 0. So what's C going to be? 0. It's the 0 vector. So that's the final answer. It's just that, right? So 3t squared over 2 I hat plus 3t squared over 2 k hat plus 8t j hat. So that would be the final answer to that one. So that's a j hat. That's a really ugly j hat. J hat. So that would be your final answer to this question. So so that's harder than most of the homework. Most of the homework, they'll give you this, and they'll say find v, so you just take the derivative. They'll say find a, you take the derivative again. Like, it's really boring. So these are the harder ones where there's some of these in the previous section too, and that we skipped. So.